This is an explanation that most of you heard in class on how to solve a heat problem that has more than one step. Remember that I said that you need to ask yourself two questions. Is there a temperature change? Yes, there is, because -12 to 123. And is there a phase change? Yes, because we have ice and we're changing it to steam. So if the answer is yes to both of those two questions, that's when you need to draw the picture. So you draw in your X and Y axes, and you put in your boiling point and your melting point or freezing point. So our question says, how much energy does it take to change 57 grams of ice at -12 to steam at 123? So it doesn't give us the boiling point and melting point. So if you don't know it, you have to look at this chart and find them. So our substance is water, so our boiling point and melting point are 100 and 0. So we go back over and we put in the 100 and the 0 and the dotted line. And the dotted line is just there to remind you to stop and let the phase change if you cross it. So then we put in our starting temperature, so -12 would be somewhere below the 0. And our ending temperature, which is 123, so that's going to be at the top. Then we draw a diagonal line from the start to the finish, but anytime we cross a dotted line, we have to stop and let the phase change, so you have to flatten out your graph for a while. And then up, and then flat, and then up. So anytime you cross the dotted line, you have to stop and flatten out. So there's 1, 2, 3, 4, 5 different line segments there, so 5 different steps. Step number 1, in that line segment, that very first line segment right there, that's step 1. We're changing from a -12 up to 0. If you're changing the temperature, you cannot change the phase and vice versa, so you can't change both at the same time. Below the melting point is a solid, in between is a liquid, and above is a gas. So right now we have a solid, so we have to leave it a solid. So since it's the temperature that's changing, we're using Q equals Cm delta T. So we need the specific heat of our substance as a solid. So our substance is water. The specific heat of water as a solid, so ice, is 2.06. So our C is 2.06 times the mass that was given in the problem, which was 57. That mass will be in every step. And then our delta T just for that line segment, so 12. Multiply those 3, and that'll tell us how much energy it takes for just that step. Okay, so there's the amount of energy for step 1. Step 2, so that would be right there. Made it blue. I tried to make it blue. 0, and it ends at 0, so this time we're not changing the temperature, so we're changing the phase. So it's a solid right now, and we have to change it into a liquid. So that's Q equals HM. So our mass is 57. We already said that would be in every step. So we need an H. Now, if you're on the bottom dotted line, you're going to be using heat of fusion. And if you're on the top dotted line, you're going to be using heat of vaporization. So right now we want the heat of fusion. So we go over here, for water, heat of fusion is 334. Put that in and multiply. That gives us how much energy it takes just to melt it. Step 3, would be this part here in red. So we're changing the temperature from 0 up to 100. So that means we have it as a liquid. That means we have to stay at a liquid. We can't do both at the same time. So since the temperature is changing, we're going to do Cm delta T. So we need the specific heat of water as a liquid. So water as a liquid would be water, so it would be 4.18. So we put 4.18 times that same mass, 57, and the temperature changed just for line segment 3, so 100. And that one comes out to 23,826 when you multiply it. Okay, then line segment 4. I don't know if yellow will show up. That's going to be hard to read, so I'll just do the number 4 with it, with the yellow on it. This one, we are going from 100 degrees to 100 degrees. So temperature's not changing. That means we must be changing phases. We have a liquid now, we're going to change it to a gas. So we need heat of, and we need mass. So we have to decide, do we need a heat of vaporization or heat of fusion? If you look up here, vaporization is always the top one, fusion is always the bottom one. So if you put those in ahead of time, then you can just look over from whatever step you're on and see which one it tells you to use. So right now we're on step 4, so I just go straight over and it tells me to use vape. So I go over, heat of vaporization of water is 2260. Multiply those two together. I think I got 128,820 for that part. And then step 5. Would be this part at the top. We have 100 degrees and we're going up to 123. It's a gas and we're just going to leave it a gas. So the temperature is changing, so that would be Cm delta T. So we need specific heat, or C. Mass is 57. Delta T is 123 minus 100, so that'd be 23. Then we have to decide specific heat. So we're at a gas right now. You can tell right there it tells us. So we go over here, and the gas, water as a gas would be steam. So we come over, and this is our C column, because these are C's. These are if you're looking for H. So 1.90. So just memorize that that column is C, this column is H, and this column is H. Okay, so 1.90. And then when you multiply that out, you get 2,490.9 joules. Then you add all those together and you get your answer. So we add 1,409.04, 19,038, 23,826, 128,820, and 2,490.9, and you should come out to 1.8. By the time you round it to significant digits, 1.8 times 10 to the 5th joules. I went with two significant digits, I think, because of the 57 and because of the 12, because you always go with the least amount. So that's how you do one of the multiple step problems.